plus 1 over negative j 13.263. We have to do some rationalization of the denominators. It's simple enough as long as you don't mistype on a calculator. All right, questions to hear? All right. So, how do we rationalize the denominator? We're going to add these fractions that have complex number and an imaginary number in the denominator. How do we add them? Or how do you rationalize the denominator? I assume it's called rationalize. I know if it's a square root on the bottom, it's rationalizing the denominator.
Multiply by 1 with like the number over itself.
What number am I putting over itself?
For the first one, it would be 15 plus, or
Something in the back of your mind is saying that it's a little bit different.
a little bit, yeah.
You can't just multiply them?
We can
Multiply them, which things do you multiply?
The denominators?
Oh, you get a common, yeah, you can do it that way, but we can save the rationalization until afterwards. But BJ, what were you thinking?
multiply the entire equation by denominator in the first one by the denominator in the second one. And then that will cancel out the denominators.
Could you use a perfect square?
Perfect
Or,
square.
I mean, like a multiply it by 15, the left side by 1, top and bottom by 15 minus j. That way
Okay.
it would make the j go away.
If you want to get rid of the j's in the denominator, you need to multiply by the complex conjugate. Ben, I think you were almost there. You multiply top and bottom by 15 minus j,
Yeah.
16.965. If you do a plus b times a minus b, you get a squared minus b squared. So you'll end up with a j squared, which is a negative 1, so you'll end up with a squared plus b squared. In essence, if you think about, I've got my imaginary and real axis here. This 15 plus j 16.95 is basically a phasor like that, and we're just finding the hypotenuse. So it comes down to at what point do you want to do that? When I did it before, I did it at this stage, but Sarah's suggesting that we wait and do it later. Or perhaps she's suggesting we never do it, but I will say that we do have to do it at some point. You want to wait or just go ahead and do this part now?
Just do
All right. So I multiply top and bottom by the complex conjugate of the denominator. So I have 15 minus j 16.95965 over 15 plus j 16.965 times 15 minus j 16.965 minus, and here we'll end up with 1 over 13.263. Let's see, wait, plus, that'll end up being plus j. 1 over negative j is equal to positive j. Because if I multiply top and bottom by j, I get j on top, and I get j times negative j, which is 1. Alright. 16.95, I'm gonna pop to the next screen. So I have 15 minus J 16.965 over 15 squared plus 16.9. Need to know where to lift the pen better. 16.965 squared plus J 13.263. So we end up with 15 minus J 16.965 over whatever that is. It's 2 something. No, it's not, it's 5 something. Plus J over 13.263. Now we will do get the common denominator. So many ways of doing this. How about if we just multiply this by 13.263 over 5112.811 and multiply the top by the same thing. 263 over 512.811. That, so in the denominator, no. I want that in the denominator. $512.811 over 13.263, 512.811 over 13.263. There we go. So that's going to cancel out the denominator, leaving us some 512.811. And in the numerator, I got 15. And then I've got this negative 16.955, that should be 965 J plus whatever that is, J.
Well, I think that is 38.653, so together 55.618.
That's negative, that's positive.
$21.688.
At this point, I'm gonna put this into just J hat into I guess polar form. Because this represents, again, on my coordinate system, 15 to the right and 21.688 up. I need to figure out what that angle is there. And then I need to figure out the hypotenuse. So my hypotenuse is 15 squared plus 21.688 squared, square root. And my angle is the arctan of 21.688 divided by 15. And could this have been done in fewer steps? That's possible.
This was supposed to be the shorter or easy way.
Well, this is the most complex of the math. We're almost past we're almost to the easy part.
26.370, at the angle of 0.9657.
All right. This is, remember, this is the impedance. So that was 1 over Z. So Z is equal to, all right, so that is just this numerator here. Z is the reciprocal of this, so it's 512.811 divided by 26.370 angle 0.9657. The amplitude of my impedance is right there, 512.811 divided by 26.37.
19.447.
My angle is, I have an implied angle of 0 here, divided by this angle, and that's, in essence, you're subtracting, negative 0.9657. We can now find the current coming out of the power supply, because this is the overall impedance, this is the everything. I need to wait before I make it go. We know when you're ready, Patrick.
Alright, I'm good.
9657, 19477. I know that I is equal to V over, for the power supply, over Z. Unlike before, when we used Ohm's law, we were just looking at the amplitudes, but now we're looking at the, I guess, the full function. My power supply, 169.706, angle of 0 radians, divided by 19 point, whatever that number was, 19.447, an angle of negative 0.946.
657.
.657. The amplitude of my current coming out of the power supply is going to be that. And my angle is going to be 0 minus negative 0.965, so I get 0.9657.
8.727.
Notice how close we are, so there's obviously some rounding going on here, but that's what we had before using phasors. This is what we have using complex math. Complex number math? Complex math sounds very different. I want to figure out what is the current flowing across the capacitor. Simple enough. Current flowing across the capacitor is going to be equal to the voltage across the capacitor divided by my Z capacitor. Well, that's 169.706, angle of 0 radians, divided by my Z6C, which is negative 16.9, no, sorry, the 13, not the 16. 13.263 angle of, it's negative J, so negative pi over 2. Oh. Yeah. So we got this negative here and a negative here, which would correspond to, hold on just a second. So it was negative J, that negative shouldn't be there. the negative was a directional thing. So that's gonna be the amplitude of the current across the capacitor.
12.795.
And the angle will be pi over 2. Which is what we have right there. Let's see, so at this point, we've got this, that, we got from the initial information, that, and that. All right. We've got the voltage across RL. Actually, we could do the current across RL. I know the voltage across RL, well, the entire combination, it's the same as we've been using. So the current across RL is going to be the voltage across RL over whatever you want to call it, ZRL. And so this is 169.706 angle of 0 over 15 plus J 16.965. I have one in polar, one in rectangular form, so we do need to combine those. The second one we've done already, I believe. So this is 169.706, 0 over, that was 512 point, no, that was a different thing. The angle arctan of 16.965 over 15. Whatever that is.
19.447.
Say it again?
19.447.
19.447. Oh, we did do that before. At an angle of
Negative 0.9657.
0.9657. Should not be negative. Do we have a radian degree issue here?
Well, because when we were finding the angle, we assumed the 512.811 was 0, so 0 minus the positive angle
Oh, you went the next step.
yeah.
All right.
That was an earlier notes from like a few minutes ago.
Oh,
That's what I was
okay.
looking at.
Well, all right, so there's the current, that's supposed to be an I there. That's the amplitude of the current going across R and L, which I assume is somewhere around 7.494 I hope. Not that. Somebody else get a different number for the angle?
Oh wait, that's the wrong one. So that it's 22.645 for the instead of 19.447.
Oh,
Okay. Yeah, I see. I know
Okay.
about one.
And the angle was 0.846.
0.846, that makes more sense, and this is 22.645.
645.
All right, and so we have 169 divided by 0.706 divided by 22.645, and then my angle negative 0.846.
Yeah, that's 7.494.
Which is what we had over here. And the last thing are these. I know that the voltage across the resistor is equal to the current across the resistor times the resistance. So that should just be, well, my current got right there, 7.494, an angle of negative 0.846 times 15. So the angle's not changing, there's an implied 15 zeros, so you would just add the angles when you're multiplying. So you get the negative 0.846. And then 15 times that should be 112.412, I hope. And then the last one, V across the inductor is I across the inductor times Z inductor. So we have 7.494 angle negative 0.846 times ZL, which is 16.965 times the angle of pi/2. One too many parentheses. And so my angle will, so my magnitude will be that times that, which I hope is 127.136.
Yep.
And my angle should be this negative value, negative 0.846 plus pi/2, which hopefully is somewhere around 0.724.
Which it is.
All the hardest part of this was at the very beginning as we were coming up with the overall impedance, but once that was done, I feel like the rest of the math was relatively simple. I am not going to specify which technique to use. I will say for the master set for chapter 33,